Hello everyone. Today we are going to study electrical discharge machining. EDM or electrical discharge machining is a non-conventional machining process. It is used for machining very hard material which otherwise cannot be machined using conventional machining processes. This process is also called as a spark eroding, spark machining, wire erosion, wire burning, etc. It manufacture process where a desired shape is obtained using electrical discharges. In this process, the metal from the workpiece is removed using high frequency electrical spark discharge from graphite or soft metal tools which serve as an electrode. This process is only suitable for metallic or conductive workpiece. This process is very similar to how a spark plug works in a petrol engine. It creates an artificial bolt of lightning in the combustion chamber. The electrical energy that it creates is extremely high. In order to create a spark, the voltage at the spark plug is nearly between 20,000 to 1 lakh volts. This is the images of the EDM equipments. The EDM process can be used in two different ways. First, the pre-shaped or formed electrode tool, usually made from graphite or copper, is shaped to the form of cavity it is to reproduce. The formed electrode is fed vertically down, and the reverse shape is the shape of the electrode is eroded into the solid workpiece. The second, a continuous traveled vertical wire electrode. The diameter of a small needle or less is controlled by the computer to follow a programmed path or cut a narrow slot through the workpiece to produce the required shape. The working principle. The working principle of EDM process is based on the working piece metal erosion with the application or spark discharge between the tool and the workpiece. When two current carrying conductors that is anode and cathode are brought in close proximity, an electrode is electric arc is formed between the two conductors, due to um, due to which at the point of contact a small amount of metal is eroded, leaving a small cracks. This spark generates intense heat, causing the metal in the zone of spark to melt and evaporate. When both the electrode that is anode and cathode is made of same metal material, the electrode connected to the positive terminal erode, erodes faster. Therefore, the workpiece is generally connected to positive terminal. That is, it made anode generally a small gap of 0.005 mm or 0.05 mm is maintained between the tool and the workpiece of the spark occur, where the tool and the workpiece are the closest. Here the shape of the tool is the same as the impression to be generated on workpiece. To increase the effectiveness of the processes, the tool and the workpiece are immersed in the dielectric fluid such as hydrocarbon and mineral oil.
Coming to the construction of EDM, we have DC pulse generator and a tool, and below that will be a servo motor. Above that will be a servo motor, and below the servo motor will be a spark generator, and dielectric fluid will be present. Coming to the descriptions of each the parts, the DC pulse generator, it converts the AC power supply into a high pulsed DC supply, which is responsible for generating a spark between the tool and the workpiece. The tool Coming to the tool should be the replica of the shape to be generated on the workpiece. That is, what is the desired shape, the opposite shape should be made on the tool. It is connected to the negative terminal of the power supply. It is the general connection. And servo motor, as the arc gap is critical, the servo motor is to control the feed of the tool. And the spark generator supplies sufficient voltage for spark generation and maintaining its discharge. Now coming to the dielectric fluid, it is generally supplied in the form of a jet at the gap between the tool and the workpiece. DNS water, silicon oil, glycol are generally used as dielectric fluids. So, coming to the working of EDM, when the power supply, turned on the DC pulse generator supplies a voltage pulse between a range of 40 volt to 3000 volt. So, potential difference is created. So, the tool and work material are conductors of the electricity. It is a main condition for this EDM, and the tool and the work material immersed in a dielectric medium. A gap should be maintained between them, and depending upon the applied potential difference in the gap between the tool and workpiece, an electric field would be established. So the workpiece is connected to the positive terminal, as I said, and the tool is connected to the negative terminal. And when this high voltage power is supplied to the tool, this causes the particles in dielectric fluid to concentrate. That is, the fluid gets ionized, forming a path for the current to flow from the tool to the workpiece. This intense arc is generated at the tool, and the workpiece interface causes the workpiece material to vaporize. In this process, a small amount of tool material is also eroded. Once the spark is interrupted, the heat is removed by the dielectric fluid, and it carries the eroded material or the metal particles. The movement of the tool is controlled by the servo motor mechanism, which maintains the gap. So it is a really nice method to do the machining of complex shapes and all, and it has various industrial applications as you can see later. And yeah, here is the schematic presentation of how the EDM works. And yeah, coming to the applications of EDM, some of the important applications are shown here. The drilling of micro holes in the nozzles and fine holes of the slots, we can be seen many parts that is being used applied in the industries, and the manufacturing of gear wheels and engraving operations, just as you can see on the right side, and the thread cutting or rotary form cutting. So these are the main applications. So coming to the advantages, as I have mentioned earlier, it is very difficult by many machining processes. The main disadvantage is that it's very difficult to machine complex shapes like fine edges or curves, which will make many shapes, which will be very important for many parts of the tools, which will be applicable in the industries and anywhere. So preparing such complex shapes is easily done by electrical discharge machining. So one such advantage is that, and it also provides good surface finish. And another problem is that the usually work pieces during machining process will undergo vibration process, which will be eroding the surface or resulting in bad surface finish. So this EDM process is not resulting in any such vibrations to the workpiece. So again, enhancing the process. So these are the main advantages of EDM, and these are the references we have used for preparing the PPT. I hope this was helpful. We have discussed about what is the EDM process and how it is important to the industries and what is its principle, the construction and the working, and we saw the applications in the industries and the advantages of EDM. And yeah, thank you.